Today's video is going to be on solving radical equations. Alright, so we're going to start off with something a little bit easier, a little bit more familiar, something that we already know how to do. So we're going to solve for x. If I have x squared is equal to 9, and I want to get x by itself, we need to square root each side. And you're probably saying, okay, x equals 3. And you're kind of right, but remember, if I have x squared equals 9, my only answer isn't just x equals 3, it's x equals plus or minus 3, because 3 squared equals 9, and a negative 3 squared also equals 9. Number 2, we have x cubed equals negative 8. So I want to take the cube root of each side, because I want to know what number, because it's x cubed, what number cubed is going to give me a negative 8. You can do that in your calculator if you don't know what it is, but our answer is going to be a negative 2, and that's because a negative 2 times a negative 2 times a negative 2 is equal to a negative 8. Number 3, we want to isolate our variable first, so we divide by a negative 2. We get x to the 4th power is equal to a negative 256. So if I have x to the 4th power, I'm going to take the 4th root of each side. So for this question, we're asking what number times itself 4 times is going to give us a negative 256. You probably don't know this off the top of your head. So when you go to your calculator, we are going to hit the math button, and you can see under the math button there's that cube root. Underneath the cube root is the x root. This means that you can take the root of any number. So if I hit 5, I want to take the 4th root of a negative 256. And when I hit enter, notice that we get an error message. It says error. Always read this. Non-real answer. It's telling you why you're getting the error message. There's the quit and the go to option. If I hit go to, it's because of the number I put underneath the radical. I cannot take the even root of a negative number because there's no number that I multiply by itself 4 times to get a negative 256. 4 negatives would make a positive, so this is a no real solution. So I can have the odd root of a negative number, but I cannot have the even root of a negative number. All right, so we're looking down at number 4. This whole quantity is being raised to the 4th power, so I need to take the 4th root because it's already isolated. The 4th root unlocks that 4th exponent, so that's x minus 2. The 4th root of 81 is 3. But remember, even roots are where we're going to have problems. When I have an even root, I don't know if that original number was a positive or a negative because that negative cancels out. So this isn't just 3, it's plus or minus 3. We move that 2 over. So we get x equals 2 plus or minus 3. But we're not going to leave it like that because we have 2 plus 3, which is 5. And we've got 2 minus 3, which is a negative 1. That's telling me that I have 2 different solutions. So I have x equals 5. That's one possibility. Or x is equal to a negative 1. All right, last one in this section. We are going to divide by negative 3 because I need to isolate the quantity to the 5th power. X plus 4 to the 5th. 96 divided by negative 3 is a negative 32. We take the 5th root to undo that. And we get x plus 4 is equal to a negative 2. We do not have a plus or minus because it's an odd root. I know my answer is a negative 2. We subtract 4, and we get x is equal to a negative 6. All right, so let's go ahead and fill out our table, our little chart here. So just remember, if the exponent is odd, then we have one real root. And it can be positive or it can be negative. It can be either one. If the exponent or root is even, so if the base is greater than 0, you're going to have two real roots, or two real solutions. If the base is equal to 0, you're going to have one real. And if that base is less than 0, so it's negative, you're going to have 0 real. You are going to have imaginary solutions. But don't worry, we're not going to worry about finding those imaginary solutions. We're just going to say no real solution like we did above. All right, so let's take this to the next level. We solved with integer or with whole number exponents. So let's go ahead and solve with fractional exponents. And if you remember, a fractional exponent is a radical. So if you have a radical, that comes from a fractional exponent. So if I have the square root of x minus 4 is equal to 2, I want to undo the square rooting of it. So to undo a square root, we square both sides. The square root and the square cancel, so we've got x minus 4 is equal to 4. We do not have a plus or minus here. Remember, the plus or minus comes from when we raise it to that even exponent, because we don't know if that number was positive or negative because it was canceled. The square root can't equal a negative number because that would be non-real, as we just discussed. So there is no plus or minus here. X is equal to 8. We do want to check for extraneous solutions. We want to make sure that it's always going to work. So I plug my answer back in, because when we have these fractional exponents, we have these radicals. We have an extra little dimension of difficulty. So we've got the square root of 4. The square root of 4 is 2. 2 equals 2. We're good to go. Next one, we have the cube root. So if the cube root, I'm going to cube both sides. The cube root and the cubing cancel, so x is equal to a negative 3 to the third power. That's negative 3 times negative 3 times negative 3. That's a negative 27. And for time's sake, I'm going to say the check works. Yay! Okay, so now, instead of seeing it as a radical, we see it as a fractional exponent. But we know that those two things are the exact same. We want to get x to the first power. That is how we isolate x. So I think about what power am I going to raise this to get it to be a 1. It's always the reciprocal, because any number times its reciprocal is going to give us a positive 1. So I raise both sides to the fifth power, and that gives us x is equal to 1024. Again, for time's sake, I'm going to say I checked it. I'm going to tell you it does work. Yay! All right, so we got to be really careful with the next two. I've got x to the 2/3 power. I need to get x to the first power. So I raise it to the reciprocal power. Again, a power to a power you multiply. So yes, that is going to give me x equals 2 to the 3/2 power. But we have something extra here. If you remember a fractional exponent, the numerator is the exponent and the denominator is the root. So there's two things that you need to be careful about. If the exponent is an even number, we have to have that plus or minus because that original number was being squared. So it could have been positive, it could have been negative, we don't know, it was squared. So when the numerator or the exponent is that even, we have to do that plus or minus. If the root is even, then it can't equal a negative number. So this is x equals plus or minus the square root of 2 to the 3rd power. We can simplify that. Bring a group of 2's from the outside. and leave one on the inside. And remember, if we have the square root, we don't have to write the 2. It's an assumed 2. And then a lot of times we do ask to round. So I would enter this into my calculator, 2 root 2, and I get about plus or minus 2.83. So the difference between exact versus rounded. So just pay attention to the directions and seeing which one we want. And yes, again, I checked it. It works. Yay! Our next one, our last one here, we have an odd exponent and we have an even root. So odd exponents don't give us any trouble, but even roots, what you have to make sure that you have here is that your even root is not equal to a negative number, and it's not, so we're good. To solve this, we raise it to the reciprocal power, which is 2/3. So I get x is equal to the cube root of 2 squared. I need 3, I only have 2, I can't pull any out. So it is the cube root of 4, which is going to be about 1.59. Okay, so the fractional exponents bring in one extra little level of difficulty there. You just have to be careful of if there is an even number, where is it at? So with fractional exponents, when the numerator, don't forget the numerator is the exponent. If the exponent is odd, you only have one real solution, and that can be positive or negative. If it's even, you have to include that plus or minus. So if the numerator of the fraction is plus or minus, or is even, you need that plus or minus. The denominator is the root. Our thing got pushed over here. If the root is odd, you have one real solution. And again, there's no trick here. It's positive or negative. You can have both positive and negative numbers. But if the denominator is even, that means that you have an even root. That means it can't yield a negative number. So you can't have an even root being equal to a negative number. Okay, that is it for our solving today.